It is acceptable to run additional wires through an existing conduit into a disconnect, then feed through to a new motor disconnect without splicing, provided specific conditions are met. Firstly, pipe size is important. The existing pipe must have sufficient capacity to accommodate the additional wires. In the scenario presented, a 2-inch pipe should be adequate for 4 additional number 6 copper wires. Secondly, wire type must be considered. All wires in the pipe must be of the same type and size, meaning number 6 copper in this instance. Thirdly, the pulling distance matters. The pipe should ideally have a relatively straight path, free from sharp bends or obstructions that could make wire pulling difficult. Fourthly, clearance is crucial. There must be adequate clearance at both ends of the pipe to allow for pulling the wires without causing damage to the wires themselves. Fifthly, electrical safety is paramount. All electrical work must be performed by a qualified electrician, adhering strictly to all applicable electrical codes. Here is a step-by-step procedure. Step 1. Disconnect power. Turn off the power to the circuit that feeds the existing disconnect. Step 2. Open disconnects. Open both the existing disconnect and the new motor disconnect. Step 3. Pull additional wires. Carefully pull the 4 additional number 6 copper wires through the existing pipe and into the new motor disconnect. Using a wire pulling lubricant is highly recommended to reduce friction and prevent damage to the wire insulation. Step 4. Terminate wires. Properly terminate the additional wires in both the new motor disconnect and the existing disconnect, ensuring secure and correct connections. Step 5. Close disconnects. Close the new motor disconnect, and then close the existing disconnect. Step 6. Restore power. Carefully restore power to the circuit, verifying that all connections are sound and the system is functioning as expected. Please note, the new motor disconnect must be appropriately rated for the additional wires and the anticipated load. If the existing pipe proves inaccessible for pulling the wires, it may be necessary to consider running a new pipe or exploring alternative methods for extending the circuit. Always rigorously adhere to all local electrical codes, and when in doubt, consult with a qualified electrician for expert guidance. Understanding conduit fill calculations is essential. The National Electrical Code, or NEC, specifies the maximum percentage of conduit cross-sectional area that can be occupied by conductors. This is to ensure adequate space for heat dissipation and to prevent damage to the conductor insulation during pulling. For more than 2 conductors, the maximum fill percentage is typically 40%. To determine if the existing 2-inch conduit can accommodate the additional wires, one must calculate the cross-sectional area of all conductors and compare it to the available area within the conduit. Consult the NEC Chapter 9 Table 5 for conductor properties including the outside diameter of the conductor with insulation. For number 6 AWG copper wire, the approximate diameter is 0.204 inches. The area of one number 6 conductor is therefore pi times the radius squared, or approximately 0.327 square inches. With 8 number 6 conductors total, the total conductor area would be 8 times 0.327, or 0.2616 square inches. Next, calculate the inside area of the 2-inch conduit. Referring to NEC Chapter 9 Table 4, the area for 2-inch Schedule 40 conduits is 3.356 square inches. Applying the 40% fill rule, the maximum allowable conductor area within the conduit is 0.40 times 3.356, or 1.3424 square inches. Since the total conductor area of 0.2616 square inches is significantly less than the maximum allowable area of 1.3424 square inches, the 2-inch conduit is suitable for the additional conductors from a fill perspective. The type of insulation on the conductors also plays a crucial role. Common insulation types include THHN, THWN, and XHHW. Each has different temperature ratings and suitability for wet or dry location. Ensure that the insulation type is appropriate for the intended environment. THHN and THWN are common choices for general-purpose wiring and conduit. However, XHHW may be preferred in wet locations or where higher temperature ratings are required. Refer to NEC Table 310.15b16 for allowable ampacities of insulated conductors rated up to and including 2000 volts with not more than 3 current-carrying conductors in a raceway, cable, or earth directly buried based on ambient temperature and number of conductors. When multiple conductors are installed in a conduit, the ampacity of each conductor must be derated according to NEC Table 310.15 cone. This derating is necessary to prevent overheating of the conductors due to the cumulative heat generated. For example, if there are 4 to 6 current-carrying conductors in the conduit, the ampacity must be derated to 80% of its original value. For 7 to 9 conductors, the derating factor is 70%. This derating factor must be applied to the allowable ampacity of the number 6 copper conductors to ensure they are not overloaded. Before pulling the additional wires, thoroughly inspect the existing conduit for any signs of damage, such as cracks, dents, or corrosion. Any damage should be repaired before proceeding. Also, inspect the inside of the conduit for any obstructions or debris that could impede the wire pulling process. Clean the conduit if necessary, using a conduit brush or vacuum. When pulling the wires, use a wire pulling grip or basket to securely attach the wires to the pulling rope or fish tape. This will prevent the wires from slipping or being damaged during the pulling process. Apply a generous amount of wire pulling lubricant to the wires as they are being pulled. This will significantly reduce friction and make the pulling process easier. Avoid using excessive force when pulling the wires, as this could damage the insulation or the wires themselves. If the wires become stuck, stop pulling and try to identify the cause of the obstruction. It may be necessary to use a different pulling technique or to remove the obstruction before proceeding. The connections at the disconnects must be made properly and securely. Use appropriately sized connectors that are rated for the conductor size and type. Ensure that the connectors are tightened to the manufacturer's specified torque to ensure a reliable connection. Improperly tightened connections can lead to overheating, arcing, and potentially fire. After completing the wiring, test the circuit to ensure it is functioning properly. Use a multimeter to verify the voltage and current at the motor disconnect. Also, check for any voltage drop or other abnormalities that could indicate a problem with the wiring. If any issues are detected, troubleshoot the circuit and correct any deficiencies before putting the motor into service. Consider the short circuit current rating, or SCCR, of the disconnects and other components in the circuit. The SCCR is the maximum short circuit current that a component can safely withstand without failing. Ensure that all components have an SCCR that is equal to or greater than the available short circuit current at the point of installation. This is necessary to protect the equipment and personnel from the hazards of a short circuit. If the existing disconnect is not rated for the additional wires and load, it must be replaced with a disconnect that is appropriately rated. The disconnect must be sized to handle the full load current of the motor, as well as any additional loads that may be connected to the circuit. Always follow the manufacturer's instructions when installing and wiring the disconnect. Grounding is a critical aspect of electrical safety. Ensure that the motor and all other metal enclosures are properly grounded to provide a path for fault current to return to the source. This will help to prevent electrical shock hazards. Use appropriately sized grounding conductors and connectors. Refer to NEC Article 250 for detailed requirements on grounding. If the conduit is metal, it must be properly grounded as well. This can be accomplished by using grounding bushings and bonding jumpers to connect the conduit to the grounding system. If the conduit is non-metallic, a separate grounding conductor must be installed within the conduit. Consider using a surge protective device, or SPD, to protect the motor and other electrical equipment from voltage surges. SPD are designed to divert surge current to ground, preventing it from damaging sensitive electronic components. SPD are particularly useful in areas that are prone to lightning strikes or other voltage surges. Select an SPD that is appropriately rated for the voltage and current of the circuit. When working with electrical systems, always wear appropriate personal protective equipment, or PPE, including safety glasses, gloves, and insulated tools. These will help to protect you from electrical shock, arc flash, and other hazards. Never work on live electrical circuits unless absolutely necessary. If it is necessary to work on a live circuit, use extreme caution and follow all safety procedures. Always use insulated tools and wear appropriate PPE. Be aware of your surroundings and avoid contact with any grounded surfaces. Before starting any electrical work, perform a thorough risk assessment to identify any potential hazards. Develop a plan to mitigate these hazards and ensure that all workers are aware of the plan. Regularly inspect your tools and equipment to ensure they are in good working condition. Replace any damaged or worn tools. Keep your work area clean and organized to prevent accidents. Remove any trip hazards and ensure that there is adequate lighting. If you are not qualified to perform electrical work, do not attempt to do so. Hire a qualified electrician to perform the work. Electrical work can be dangerous, and it is important to have the necessary knowledge and skills to do the job safely. Always follow all applicable electrical codes and regulations. These codes are designed to protect people and property from electrical hazards. Stay up to date on the latest code requirements and ensure that your work complies with these requirements. When in doubt, consult with a qualified electrician or electrical inspector. They can provide guidance on how to safely and properly perform electrical work. By following these guidelines, one can safely add wires to an existing conduit run for a motor disconnect. Remember to always prioritize safety and consult with a qualified electrician when needed. Regarding specific NEC references, remember these are for example and you should consult the latest edition of the NEC. NEC section 300.17 addresses raceway fill. This section states that the number and size of conductors in a raceway shall not be more than will permit dissipation of heat and ready installation or withdrawal of the conductors without damage to the conductors or to their insulation. NEC section 310.15b3 provides the requirements for adjustment factors for more than 3 current carrying conductors in a raceway or cable. As stated previously, these adjustment factors reduce the allowable ampacity of the conductors to prevent overheating. NEC section 314.16 covers the requirements for box fill calculations. While this section does not directly apply to conduit fill, it is important to ensure that the boxes or enclosures connected to the conduit are also properly sized to accommodate the conductors. When selecting conductors, consider the voltage drop in the circuit. Voltage drop can occur when the conductors are too small or the distance is too long. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. NEC section 210.19 AM provides guidance on voltage drop calculations for branch circuits. The recommendation is that the voltage drop should not exceed 3% for branch circuits and 5% for feeders. When pulling wires through long conduit runs, consider using intermediate pull points. These pull points can help to reduce the pulling force and make the pulling process easier. Intermediate pull points can be achieved by using pull boxes or junction boxes along the conduit run. The distance between pull points will depend on the size and type of conduit, as well as the number and size of conductors. When terminating wires in disconnects or other equipment, use appropriately sized wire connectors. These connectors must be listed and labeled for the intended application. Ensure that the connectors are properly tightened to the manufacturer's specified torque. Over-tightening or under-tightening connectors can lead to loose connections and potential hazards. When working with aluminum conductors, use connectors that are specifically designed for aluminum. Aluminum conductors require special connectors to prevent corrosion and ensure a reliable connection. Aluminum connectors are typically coated with an oxide-inhibiting compound. When installing conduit, ensure that it is properly supported and secured. Use conduit hangers or straps to support the conduit at appropriate intervals. The spacing between supports will depend on the size and type of conduit. Refer to NEC section 344.30 for specific requirements on conduit support. When bending conduit, use a conduit bender that is designed for the size and type of conduit being bent. Avoid kinking or damaging the conduit during the bending process. Sharp bends can restrict the flow of conductors and make pulling wires difficult. After installing the wiring, perform a continuity test to verify that all connections are properly made. Use a multimeter to check the continuity between the conductors and the grounding system. This will help to identify any open circuits or short circuits. Also, perform an insulation resistance test to verify that the insulation and the conductors is intact. Use a megometer to measure the insulation resistance between the conductors and ground. Low insulation resistance can indicate damaged insulation and a potential shock hazard. Label all disconnects, panels, and other equipment to clearly identify their purpose. Use permanent labels that are resistant to fading or damage. This will help to prevent confusion and ensure that the correct equipment is de-energized when performing maintenance or repairs. Keep accurate records of all electrical work performed. This includes the location of wiring, the size and type of conductors, and the ratings of equipment. These records can be useful for future troubleshooting or modifications to the electrical system. If you are unsure about any aspect of electrical work, consult with a qualified electrician or electrical inspector. They can provide guidance on how to safely and properly perform the work. Electrical work can be dangerous, and it is important to have the necessary knowledge and skills to do the job safely. Always follow all applicable electrical codes and regulations.